Hello. Hello. I can hear you guys. Can you guys hear me? Hello. Sorry. Hello. I can't hear you clearly. Hello. I'm not allowed to share my screen. Can you look into that one?
Just a minute. Have you tried out to share?
Yes, sorry. Hello.
Yeah, can you share now?
I can hear you, but it's echoing. Anyway, let me share
No,
my screen.
I think you are clicking only window. You click entire screen.
Okay, I can share my. Let me share my screen. Yeah.
Yeah.
Is it visible?
Yeah, it's visible.
Okay, it's all good. Let me stop sharing right now then.
Yeah, okay. Just we will
Yeah, sure.
we will start again at 2:30.
2:30, right? Okay, I will join again back in like 5-10 minutes. Okay, then
Okay, done. Thank you.
let me set up the system. Okay.
Yeah, thank you. ऐसा करके तो इसमें लगा रो लगा रो बच्चे काम करके भी कई बार रवि सर 2 मिनट है ये बच्चा तो मेन भी नहीं खाली जीरो जीरो फिलहाल मैसेज कर दिया है डेट नेम ऑफ द स्टूडेंट नहीं दिखाई डोर सॉल्व इसके बारे में इसके बारे में वो बोले सर तो मैडम बोले सर परमिशन लेके आए तो क्या मैडम परमिशन लेकर आए मैंने तो इनविटेशन किस किस को है వీళ్ళు కూడా ఆపరేట్ చేస్తారు చూద్దాం లేవు నా పెట్టండి రేపు చెప్తున్నా లేవు 2:30 కదా స్టార్ట్ చూపించాడు మేడం దగ్గర ఉన్నాడు ఏం మేడం ఫోన్ చేసి నేను మాట్లాడతా जल्दी आओ क्या हुआ सीबीआर वाला अच्छा करा सर सीबीआर ईसी डिपार्टमेंट वाले फैकल्टी डेवलपमेंट वाले रिसर्च के ऊपर करे 380 तक अटेंड मिला सर ऑनलाइन 380 रेगुलर 380 300 तो
Hello. Am I audible? Hello. Am I audible? Hello. Hello. Can anyone confirm? Am I audible or how is it?
Not sir, not audible, sir.
Hello. Is it now? Is it good now?
Yes, sir. Now hearable.
Okay. Great.
Good afternoon, everybody. I'm Dr. I welcome you all for the fourth day of faculty development program. I request everybody to please uh, have patience because we are starting the program at 2:40 exactly. Thank you, everybody. Good afternoon, everybody. A warm welcome to the 4th day of our faculty development program. I hope the yesterday's sessions were informative and thought-provoking. Today we have another exciting lineup of sessions and discussions. Let's get started and make the most of this opportunity to learn and grow together. Today we have our a speaker, Hardik Paramar, who is a composite structural engineer at Tradewell Group. He's also IIM Ahmedabad alumni and chartered engineer. If you talk about Hardik Paramar, he's an innovative and enthusiastic mechanical design engineer within the manufacturing industry. His significant design experience in engineering for product manufacturing industry. If you talk about the Hardik Paramar areas of expertise, he is a creation of a concept 3D models and layouts using CAD software like SolidWorks, Creo, Inventor, etc. Validation of design with theoretical calculations. Is also aware of ASTM, ASME, ISO standards and its applications. He has analyzed the design in the simulation software like ANSYS, Nastran, and etc. Is also involved in initial concept design, following through manufacturing and final assembly with technical writing and documentation responsibilities. He provided design engineering support for the economic design of structural components, facilitated the transfer of new products from design to assembly. He's also having a hands-on expertise with both bottoms-up and top-down approach in design the product design capabilities, including DFMA, which is designed for manufacturing and assembly, and FMEA, which is failure mode effective analysis. He ensured the information is communicated efficiently and effectively, ultimately strengthening internal relation process. Now, I request our today's speaker, Hardik Paramar sir, to go ahead with the session.
Hello, thanks, Madhukar. So let me start with, hello, can you hear me? Hello. Hello.
Sir, hope my voice is audible. Hardik
Yes,
Paramar, sir.
I can hear you. Can you guys hear me? Hello. Can anyone confirm whether I'm audible or?
You're
Yes,
audible,
okay.
sir. Please go ahead.
Thank you. So
Yes, sir, you are
let me
audible.
share my screen. Yeah. Thank you, Madhukar. So I'm starting today's topic. So my title is a research design and methodological framework. So I will be like focusing more on the practical and our engineering applications from the industry's perspective. Talking about myself, like I'm a chartered engineer with the Institute of Mechanical Engineers. I did my executive education with IIM Ahmedabad, and that was a government project. So I will be sharing some of the government-related research projects as well. Little bit an overview on that. And currently, I'm working with the Tradewell Group, which is an Australia-based company. So it works on the composite structures and various FRP, new product developments and all. So yeah, I will be sharing some of the research design which I did for Tradewell and some other industrial perspective as well. So yeah, that will be the whole project, whole session for today. So this is about me. Like, yeah, I got recently, like, I'm currently a chartered
Hardik, you can make the full slideshow.
Is it visible? Okay. Sorry. I thought it's visible. Okay. Is it okay?
And also you can close down Google Meet window. Yeah, you can close, no issue. You can close.
Yep. Just
Yeah, good to
give
go.
me
Thank
a
you.
hands up. Yep. Okay. All good. So, yep. So for me, like I'm currently a chartered member of Engineering New Zealand as well. So I got that designation recently. Chartered engineer with IMechE since 2020. Got an alumni of IIM Ahmedabad from 23. Did my master's in mechanical machine design and bachelor's in mechanical as well in 2013. I am having an academic experience of as an assistant professor as well from 2015 to 2017, and but during that time, I was more inclined toward working on research and development and related to industry sectors as well. So I joined an industry in 2017 and still working on that one. Currently, I'm having a designation of manager in as an engineering and technical of Threadwell Group Australia. So regarding today's topic, so I'm giving you a brief about there are different types of research. So the major types are qualitative, quantitative. Third one is a mixed one, applied, fundamental, and experimental. So I'm talking about in detail for all of them. So first is the qualitative. So what does the qualitative research mean? So it covers the topics or research methodologies which are having focused area, not in numerical values. For example, if you are doing some research for the public sector or some projects which doesn't depends upon the data, but it's more of an observative kind of thing or having the deep research, then it's a qualitative thing. Quantitative research means the research which has the numerical values, which is the data driven. So that parts comes with the quantitative details. So quantitative details are also includes the projects, for example, like government projects or the details like if you are in engineering, you use various tools such as in from the Power BI of Microsoft to FEA simulations, or even in what we say as a research tube and Excel files and list of other softwares. So that will be covering the quantitative methods. Mixed one are compiling of both qualitative and quantitative. So it has the several part which covers the basic fundamental research, and then it also has the numerical data. So most of the recent projects and are having the mixed methods. Fourth one is an applied one. So applied one basically works with the details like what we do in a physical engineering related data. Wherever we applied certain principles, we apply certain rules and data which we have already got. It's a perfectly what we say a theoretical approach to do a research and analyze what we have as in data. Fundamental research is a basic research methodology. It has the certain values. For example, if you are looking for certain topics and going into depth for that one, let's say I'm looking into the composite and if I search for the composite matrix or different products of composite, then it will be a fundamental research topic for me. Similar way, an experimental will be what we do in a testing laboratories, what a quality engineers and a QA labs are doing. That's an experimental research. They do a product, they do a methodology, they do simulate and found out some research and get some output data. So that's an experimental research. Now, moving forward, like this is the research trends and research methods. So I'm not going into much details. I'm just giving an overview. So 20% of all the projects or whatever research is ongoing it's a qualitative. 50% is a quantitative, and remaining 30% is a mixed one. Why quantitative is much more? Because you see there are very large amount of data available in the market, and in the global trends we are having so many data which we can analyze with. You see there are tools like Python. You have used seen the words like Power BI. You have seen the words softwares like R. So these are the softwares which are research analyzer, and they do use a lot and generate an outcome. And this outcome are used for forecasting and analyzing the future data and how the trend is ongoing. So that's the research methodology called as a quantitative one. Mixed one has the both of them, like quantitative and the qualitative. So mixed one is more of an uh, what we say a long-term kind of process. So it has the qualitative one which is already done, which is in a theoretical one. And out of the whole research database, what you have, some of the data which are the numerical one and get is analyzed for what we want to achieve. So based on that, we are getting the mixed one research methodology. The next one is the most important one, is a problem formulation. How you formulate the problem. So there are several key steps. So this is applicable to all of the problems, even if you guys are faculties, right? So when you have having a projects from the students, or even if you are working throughout the thesis or doing a research paper, you identify that every problem needs to be having a certain steps. So these are that. So this is a broader terms. So first one is definitely you identify the gap, like why you are choosing this one, why you are having what kind of method, or what do you have right now, what you want to achieve. That gap is first needs to be identified. Then from that gap, you define the scope. It's not like you will be doing the whole thing at once. You define a particular scope. For example, if you have number of items, let's say 10, so you don't work on all the 10 gaps from one stage A to stage B. You only work throughout the particular 2 or 3 things which will be defined as your scope. Then the third step is a review of literature. As you see, like there are number of research papers, number of journals, number of things and research parallel ongoing across the globe. So you review that literature. So literature doesn't mean that whatever thing you have available as in the research paper or technical journals. Now with the AIs and all, you also need to go a little bit deeper in what actually even in a practical stage we are getting, so that all the details comes under the literature. And the last one is a frame a problem, like identify the thing. Let's say for you guys are also working on a research paper, so the title is what we consider as a framing the problem, like how to identify thing, how to design and analyze the problem, how to design and analyze the structure. These are the kind of a problem which we frame as a whole part. Next one is hypothesis development. So this is the most important part. So it has several components. So hypothesis development is a thing in which like the whole idea, whole base of the research is like developed. First one is a predictive statement, like how you are predicting that, okay, this is what I'm expecting. Throughout the process, you have certain things in mind, right? That this is what I want to achieve. Out of that, there will be a several of data which you can test it and you can analyze that one. So that comes under the testable data. You see, previously I mentioned that there are some parts of a qualitative and quantitative. So predictive statement comes after your qualitative research. Then testable data are the one which you are going through the quantitative one. And then there will be a null versus alternative. So during the process of research and going through your whole research journey, you will identify that, yeah, this is the data I have, this is the data I can generate, and this is an alternative method which I can found and work through as well. So that is a part of the whole hypothesis development. You work on that base. This is a main frame throughout the whole of your research project that will guide you through the next step. So yeah, and another thing. So this is also how we say a smart one. So research objective needs to be a smart. Smart, that means specific, measurable, achievable, relevant, and time bound. So specific, I would say, as I mentioned previously, like you have certain things as a stage A, you have certain things as a stage B. Now you identify that, okay, there is a stage A, there is a stage B, you have the gap. You identify that there are 10 number of gaps, but you need to be very specific. Yeah, I will not be working on all the stages. For example, like if we have 2 countries, for example, if we are going from working towards going from India to Sri Lanka, so if we have number of road sites, so it's not like, okay, I will go from anywhere. No, we need to be very specific. Okay, this is my path. I'm going to this route. So we make it very specific, right? So that's how our research methodology works as well. We need to be very specific. We don't need to work on all of the things. Second one is a measurable. Yeah, definitely. So whatever we have, whatever number of objectives we have, we need to be a certain measurable one. Our output will depend upon what was we were having it previously and what we are able to achieve it now. So that's the measurable one. Like if you are able, for example, if you have something which is giving a 50% of efficiency, and now your efficiency, you know that it's improving, but you need to have some data, right? So that's how you will be able to generate and you will be able to measure. So yes, the second objective will be is a measurable one. Third one is achievable. Research definitely, like it's a long-term thing. You might get number of delays, and it might take a longer time than you expect. But definitely, you should be having some goals, some Gantt charts through which you will be working on. Right, every research project, whether it's a student project, whether it's a research paper or the thesis, or if you say a PhD one or the long-term journey, right? It should be achievable. It should be having a timeline. So once you start, like you need to be having that thing in mind that yes, this is the date, this is what I want to achieve. And again, that goes back to what you have as an objective, as a specific. As specific as you are, that it will be definitely achievable and measurable. So it's like that. Fourth one is a relevant. So this is a main part. Lot of researchers go off the track because or have the output which is sometimes not relevant to that thing as well. You need, when you are doing some research, you need to be very specific on this part. Like I said, like for example, in one of the project which I faced, so I was working on one of the structure which is made through a composite material. And during that material, working throughout the material, I found that, okay, yeah, if I work on this section or this connection, it would be easy like that and structure would be fine. But was that a relevant topic? No. Was I working on the connection part? No. Then it was not an objective for me at particular time. So I was off the track on that point. Yes, definitely it's a good thing for the company. But whenever I was working through the project, I need to be very itself. Fifth one is a time bound. Yeah, so time bound is very critical. Like whenever we are doing some research, we need to have certain time amount. It needs to be having some flexibility. Yes, some allowances should be there, but definitely a time bound objective is a preferable one. That's how like we get a time, like in India we have certain time limit of for the project 3 to 6 months. Then it's a midterm project, let's say 3 to 5 years, or long-term project more than 5 years. Why it is like that? Because you need to be achieving the objective within certain time itself. We don't want to go into much deeper. Like if you can go into detail with all the projects, like okay, yeah, we can work on this project for the couple of years, or let's say 10 to 20 years as well. But that's not your objective, right? Your objective should be, yes, we are going to achieve this thing within this time period. So that's a time bound thing. And yes, again, like again, charts, timeline preparation, that will be a very useful tools for the preparing your research objective. Next one, yeah. So from here, I'm going through the case studies, which I did some research and I have some base things in mind, because I think this is the best way to get to know you through the research methodologies. This is the first case study I'm mentioning. So one is a structural performance optimization of FRP creating under dynamic industrial load. So let me just guide you on this part. So FRP gratings are the ones which you guys are saying through the drainage line, which will be having when you are passing through the drainage portion or having a chemical harsh environment, there is a grating on which you put your legs and just walk around the industries. So that's an FRP rating. So here the case study was on the structural performance and optimization with the industrial loads. So with this the whole research project, what I was having as a background was a chemical processing plant that was having a premature deformation of a conventional steel gratings near the pump areas. Why? Because it was having so much vibration. It was also exposed to the corrosion. So a client requested a corrosion-free and a lightweight long life alternative. So what I did, so my research problem here was a although FRP rating was widely used, it was having a limited field data existed for the dynamic load effect in the vibration reduced environment. So this was my research problem, right? Because I was not having so much of data. So why? So for me now, the next step was to framing a question. So how did I frame it? So my question for me on the research topic was, how does the continuous dynamic loading affect the stiffness, damping capacity, and long-term deflection of heavy-duty FRP grating? Now you see here I mentioned FRP gratings that I know from the project itself, right? But I want to know what can I do with FRP grating? There are so many things, right? So I need to be very specific. What I did, okay, I will analyze and work on the dynamic loading effect. Now, what will dynamic loading effect will do to FRP? Stiffness, damping capacity, long-term deflection. That's the three things, right? I can also work on durability, number of other things, FRP composition, but yeah, no, I make a specific thing. I worked on the specific part of FRP. So that was a research question, and that's how I framed my research question on that one. Now I was having a two hypothesis. Now first one was, okay, dynamic vibration loading does not significantly affect FRP grating stiffness. And second one, okay, dynamic vibration loading significantly reduces stiffness and increases long-term deflection. This is both of the hypotheses I was having. Now I need to work on both of them. That's how my research is guided, right? I have a methodological framework developed on that one. Then first one was an experimental setup. What I did, like I have some vibration applied over the FRP grating. For what cycles? Okay, this is again a little bit of technical. I'm just sharing that it is so. When we do a cyclic vibration test, we get certain data, right, as an output. So that's how the experimental setup I did. Then strain gauges need to be placed near 6 critical points so that I can analyze the vibration and comparing both. So there are two different types of FRP grading system. One is ISO and another one is a vinyl ester. So I want to do the both of them experimental setup. So that was a part of the my methodological thing. Second one was a data analysis tool. So I can analyze the frequency response analysis in a Python, do the simulation, and I can get the data. I can measure that, okay, at particular this cycle, I was having this vibration, and yeah, this is the response. Similarly, for another data, I'm getting this response that I can analyze it. Second thing was model behavior measured in LabVIEW. So LabVIEW is again like when we do a physical testing and all, I will get some data, so I can model that behavior. Third one is a regression model to predict the fatigue-driven deflection. Why? Because let's move back to earlier. See, here I have mentioned, right? I want to measure the long-term deflection as well. Now, long-term, I don't need to wait for 3-4 days continuously or doing this simulation again and again. So what I can do, I can analyze the data and predict the fatigue-driven deflection. So that's how I want to limit my time of the research and get the data. Last one was, what's the result I'm getting? Okay, so I'm getting the result as, okay, vinyl-based FRP showed 38% higher damping capacity. Now, this is 38 isn't actually quantitative data. This is what I was expecting as an outcome. This is a measurable thing. Long-term deflection reduced by 27 in high-grade glass fiber weave. So 27% is again like measurable outcome, right? I'm getting something which I can measure. What was this doesn't mention like, okay, this is, I was having 5 mm deflection, now I'm getting 4 mm deflection. Not like that. You just need to mention, okay, how much is that's reduced, because 5 mm or 4 mm input and output depends upon the particular portion, whereas 27% gives you an overall scenario. Like it doesn't depend upon the particular thing or in an output. It's a generalized term. So that's what we want as a research thing. Fatigue cracks in steel equivalent to appeared at 480K cycles, none in FRP. So that means like whatever result I was getting at 480K cycles in a steel, that's not available in FRP. So that's what I'm getting as a result. And with all the result, I'm getting certain thing as an outcome. So my outcome for this case study was the plant replaced all the steel grating with vinyl ester FRP. Yep. What I'm gonna achieve with this one? 4 crores longer life expectancy. Yes. 70% reduction in maintenance and zero corrosion related downtime. Now, this is definitely a material based things, but 4 crores and 70% reduction. How I get that one? Due to my research, because I found that okay, it's a 38% higher damping capacity. I have some data from the steel, right? Now with FRP, I'm getting okay 38% higher damping capacity. So that means whatever creating of steel I am having, I can replace that one, and the amount of life force is increasing. And same thing for the maintenance. Now, as mentioned earlier, so steel grating was getting corroded, and I need to maintain that thing. Or where there was a vibration, so need to replace the fastening, screws, nuts, bolts. So with this one, definitely, if it is not vibrating that much, so yes, my maintenance time will be reduced. My maintenance cost will be reduced. So this is an outcome. So this is in one part. Let's go to another case study. So this is again like a, uh, have you seen like there is an excess hedge. So I will explain the thing. So when we do have an oil and gas thing or something as a chemical environment or something which you don't want to go into, but you just want to analyze or having an access or what's going in inside, just like what we have on a water tank or the boiler things and every power plants. So we do have some areas through which maintenance guy or then operators can just having an access. They sometimes use this for the inspection purpose, sometimes use that for going into that one. Now, in most of the industries, this excess hedge are having a support arms. So support arms are like so that it can automatically close it or open it. One of this project is here I'm just talking about. So an industry OEM, that's an operation engineering and maintenance, reported that were two SS316 support arms for an XSH that failed to maintain the stability under windy condition. Now they required a redesign mechanism with either steel or FRP. Here, what will be my research problem was there was no standard model existed for buckling versus bending versus rivet shear in hybrid FRP metal hinge system. So that's how I created a research objective to design, validate FRP-based hinge or strut system with predictable load capacity, matching or exceeding SS316. Now you see here, what was my concern? SS316 support arms that was having a stability. So stability, I consider it as a design and validate for the predictable load capacity. So that's how you formulate the research objective. And now the next step was the hypothesis. So hypothesis for me was like, okay, hybrid FRP stainless assembly can outperform pure stainless steel arms due to higher specific stiffness and corrosion resistance. This was hypothesis I made. Next step was to methodology. So what I'm gonna use, like I was able to do a FA simulation. So I actually used Inventor Notion, but previously I was thinking to use Go for Abacus as well. That's much going into detail, but just giving an overview. So Abacus is software used to determine the different layers of FRP. Whereas Invent and Aston, you can use multiple material at single time. So we used both of them to simulate. What I did as a simulate, okay, I did a 350 long FRP flat, 5 thickness, rivet shear behavior, twin load simulation 0 to 1.8 kilonewton. Now, why I need to mention this data? Even when we are going to explain this to what we say, when we go into plant or somewhere like, for example, if there will be a management call on this one, right? So still, we are gonna use this data. Why? Because that's the numerical data, what I was having. That's a part of my quantitative research. So need to mention that thing that, okay, this was my methodology. Then what was that? Yeah, the next step was a prototype testing. What I did is a 20 physical load test. I did one and got the data. Second, got the data. Then after that, I got 20 physical load testing data. Another thing, what I did was a strain mapping using a TIC. TIC, that means a digital image correlation. So that's also a part of using a different tool and getting some data. With prototype testing, yes, this is a part of experimental setup, and simulation is a part of theoretical data setup. Okay, so what I was getting as a result. So result I'm getting is, okay, FRP arm supported at 2.4 kilonewton versus 2 kilonewton is still equivalent. Okay, that means FRP arms can support more load, right? Rivet shear failure reduced by 22% using a hybrid SS316 plus FRP washer system. Now you see, I didn't mention what was a rivet shear failure earlier, right? I didn't mention that what I am getting as a result. I just mentioned, okay, this is what I am getting, 22%, because that's what the result is. I don't need to mention. I don't need to mention what was my hatch size, what I am working out about. So hatch can be 200 by 200 as an inspection hatch. It can be a excess hedge for the person going inside the boiler or the plant, or just a small hedge area as well. So this is the result I'm getting as a general term. It needs to be okay. I'm getting a 22% shear failure reduced. Third result was I'm getting as a wind-induced oscillation by 41% lowering FRP due to inherent damping. So this is also one of the results I'm getting. Now, based on this research and the results, what I'm getting as an output, okay, we developed a validated engineering document and a design that later on approved by client. So this created a repeatable FRP XSH solution for future projects. Not just current one, but it's a validated engineering document. So you see, when that's the industry standard documentation as well, right? We have certain documents. For example, we see that, okay, this company uses ISO 9001 standard. This company uses 14001 as an environmental standard as well. But there are certain documents which company uses for their own internal purpose as well. This kind of document, one I'm showing you through the case study too, which can be used as an internal validated engineering document as well. So this will be this is an outcome. Now from both of the case study, I guess I have one more. Yes, but before going to the third one, so I'm just gonna go through the process. So first one is background. Second one is what you identify as a problem. Third one is making an objective. Fourth one is a hypothesis. Fifth one is a methodology. Methodology includes both of the thing, whether qualitative or quantitative and experimental setup, everything. Then there is a result and an outcome. Now, there is another case study. So now we are talking about more of an AI things, right? So AI things are also used in an industries. So how I use this one, this is still an ongoing thing. So I'm not able to provide you much more details, but it's still ongoing. So this is like more about how you predict the model for FRP corrosion degradation. Now we know that, okay, the composite don't degrade easily. Like steel has certain life cycle. FRP also has a life cycle, but as it is a composite material, so it depends upon number of other things. What if one part of the material is not getting affected, but another part of the material which is having an environmental effect? So that might be used for the prediction of how the life will be for that particular product. So I'm having some background data as, okay, long-term test data for FRP corrosion that was inconsistent across the suppliers. Second thing, the lack of predictive modeling created uncertainty in engineering design life cycle. This is the background I am having. Now, what will be my objective? Yes, use some AI-based analytics to predict 20-year degradation of FRP in different chemical exposure. Like I said, like I'm working to an Australia-based company which is having a lot of mining sites, lot of corrosive environment, and some of the industrial areas were having a chemical exposure such as nitric acid. So I used that kind of different chemical exposure and used that data, and through the AI, I want to analyze what will be the life of for a particular product after 20 years. Now, what methodology I am using? So I'm having a data set of 200 plus historical corrosion tests, that I have number of project data, and I have the quality data set, all the testing results and everything. So it was somewhere around 200 plus. So I'm having that data set. What that features? It has the resin type, it has the fiber percentage, it has the chemical data set, it has the temperature data, it has the immersion time. What I'm gonna use this thing, I'm gonna use the models as random forest data exposed. So these are the different models. LSTMs, that's a time-based prediction. I'm gonna use these models with an AI so that I can predict the details. What will be my finding? So this is just an outcome, it's not complete. So from the XG post, I predicted that, okay, the degradation will be with 92% accuracy. You see here, I'm not giving you an exact data, okay, this will be how much it will be degraded. This I'm getting as an accuracy. Why? Because it's an AI driven predictive model. It's not like uh, having the complete FRP corrosion degradation over the life cycle. I'm just having the data through the AI. That's why. Now identifying 3 high-risk chemical environment for the V resin. Now, obviously, with AI, I will be able to find out that, okay, with V resin for certain, for let's say for the nitric acid environment, I'm getting this life. For another area, I'm getting this as a life. So that's 3 different chemical environment data I will be getting. Third key finding will be led to new resin selection guidelines. Yes, I will be able to have a my own guidelines. This parts needs to be tested. This parts needs to be checked before selecting the resins. So that's how I will be able to have my new guidelines of my own for the based on the my whole research, and what I will be getting in as an outcome. So yes, help establish a data-driven method for FRP design life estimation. That's that will be an useful the engineering submission. Why? Because this is the data I'm gonna use for the sustainability part of what we say as an ISO 14001 standard. So this is a part of my third case study. Now again, like just going back to the what we say during the SMART objective. You see, in all of the 3 case studies, we specifically measure what my objectives are. We have that thing. Okay, what I'm gonna measure. Third one, yeah, definitely I mentioned what I'm gonna achieve. Wherever, but if it is first project was having a deflection, I got the result as in deflection. If it was a stiffness, I got some data on stiffness. Damping capacity, yes. How much is gonna affect? Relevant, yes. In the all projects, I was very relevant on the topic. What was I was having as a research. I kept my project throughout that line. Time bound, yes. every project was having certain timeline, whether it's a 3 months, 6 months, or 1 year. It was a time-bound project. So yeah, I make this one as a smart one. So this is how we should making an objective. Hypothesis, this is how we make a component predictable, testable, null versus alternative, all of the things. You see, in several case studies, I also mentioned that, okay, this is the data I was having, and this is the experimental setup I was having. Why both of them? Because I want to test, okay, whether there is a convergence or not, whether both the data are matching or not. If one data is more accurate, one is not, then I need to be sure on that one. So this is a part, and also again, like a problem formulation, again, very important part, how I define a one-line question, one-line problem, that this is what I'm gonna do. It is based on what I have as a background, what I'm gonna achieve. So this is a part of what I did under the industries. Apart from that, so this is just a certain things by what I did during my research projects at IIM Ahmedabad through the government. So I was working under the Ministry of Skill Development with an IIM fellowship program. So what we do is, like, you see there are a number of ongoing skill activities, right? That project should be specific to requirement. You need to match the demands of a skilled person. So how we do the data, like we have certain data, like, okay, for example, ITIs are having 60 people, and out of 60, 35 persons are passing out through zero backlogs, are going 100%. Out of that 35, 20 or 25% are getting job. So this is the data, right? Now we need, okay, there are for certain areas where your guys are having requirement of 40 people. So how you manage that one? Because you're only getting 25 people at a job, 35 as a hiring. Still you are having 5 people which are not getting the job. So you need to frame that thing, that, okay, this is how the project should be identified. This is how your goal should be. And that's how you do the research and come up with a new project and use that thing for the developing the whole new project and get that as something as an outcome. So this, yeah, this was my journey. And sorry if I took a longer time, but I think we are still having some time. So I have few more government projects as well. Okay, I don't have that details, but let me share you one another example. So you see, at every district level, you guys are having one as an employment fair nowadays, right? So in employment fair, the government has launched this part as an apprenticeship. That whatever the whoever is passing through the government bodies or any institution, right, they will be getting an apprenticeship in the industry. Apprenticeship also covers certain remuneration. In that remuneration, for example, let's say a person is getting 8,000, right? So out of that 8,000, let's say 5,000 or 6,000 is paid by company, and rest paid by government. Why government mandated that thing? Because see, in a growing part of India, so we are having a highest number of youth. So people were getting more easy job and don't want to look for the longer term side. And industries are having more requirement of more than experienced person. They don't want to spend much more money and going through the training and all. So okay, that was a part of one of the research thing that government identified. Okay, what if they do intervene and provide some support to industry as well as to students who actually wants to do something in industry sector, do some training part. And that's how the apprenticeship things comes into the market. So this is also one of the things which is not for longer term. So apprentice don't work for more than 6 months or 9 months, but yeah, it is still a useful, right? So that's also a part of one of the qualitative things, and that comes into the quantitative research study. And we got something as an outcome as a apprenticeship job fairs which is running in every district. I guess so, and yeah, that's a part of a government research study as well. So yeah, this is my part. So I'm open to questions to all. Thank you all very much for listening to me. You guys can contact me through email as well. Also, I'm very much active on LinkedIn as well. So here is my LinkedIn ID. You can just type in that linkedin.com/in/Parma Hardik, and yeah, I'm easily contactable, and you guys can ask me any questions related to my studies or anything related to it. Again, thank you very much. I'm gonna stop sharing and going. Give me a
Thank you.
question. So yeah,
Thank you, Hardik. Participants anywhere, you can unmute yourself and ask
please.
for the questions here. Yes, sir. You can go ahead. Participants, if any participants have any query, please.
Anyone has any questions related to anything, like I'm open to have both of the things. Either you want to ask a question related to industrial research, or if you have any questions related to government research methodologies, I can answer the both. Just don't ask me too many things on government part, because yeah, a lot of the things were having some non-disclosure agreement kind of thing, so I cannot share. But yeah, I can give you an overview how the methodology is. So yes, if you guys have any question, please go on. Anything? I have some. Okay, that's just comments.
Okay, Hardik, I think they can contact you on LinkedIn if I have
Sure,
anything.
definitely. Yeah, you guys can contact me on LinkedIn as well, or you can ask
Because we
Professor
have
Madhukar
disabled
as well.
microphone till now. We are only enabled
Okay,
now. So participants
no
were
worries.
thinking their mic is still unable.
Okay. No worries. I completely understand that one. That's fine. Anyway, so all the participants can definitely contact me at any time on LinkedIn, and you can ask Professor Madhukar as well for my contact details, or if you have any questions, you can go through him as well. I'm open to you guys anytime. Yeah, over to you, sir. I'm all good.
Yeah, thank you, Hardik. I now over transfer to Sapna sir, please.
Thank you, sir. Good afternoon, everyone. On behalf of organizing committee, I extend my sincere gratitude to Mr. Hardik Parmar, sir, for today's insightful session on research design and methodological framework. Your clear explanation on type of research, research methodology, problem formulation, hypothesis development, and some of the case studies have truly enriched our understanding. I also thank all my organizing team and for constant support, and a special thanks to all the participants who are actively participated today. Thank you everyone for making today's FDP successful. We look forward to meet you in the next session. Thank you everyone.
Thank you, Hardik. Thank you, everyone. So
Thank you.
all participants can drop your feedback and leave a rating. Thank you.
Thank you. Yeah.